Good morning. Good morning. Good morning. Excited to kick things off with our very last Tech Talk here at the Redwire booth. It is my honor to introduce to you our panelists. We have astronaut Dr. John Grunsfeld and moderated here. He is a legend. And moderated by our very own Chief Technology Officer, Tadros. And take it away.
Great, thank you, Terry, and welcome everyone, and welcome to the last day of Space Symposium. Great weather all week, great show, a lot of exciting activities, a launch this morning, and now the highlight, this panel discussion with Dr. John Grunsfeld. As many of you already know, John's been involved in a lot of servicing activities with Hubble, and we're going to hear a little bit about that. But he's also been very active, recently and with Redwire in looking at what's the future of space and space architectures. So I'm actually going to let John introduce himself, but to avoid him being too humble, John has been on multiple spacewalks servicing one of the few persistent platforms in space, the Hubble Space Telescope, and he's a hero in many ways because of the recovery of the early flaw on Hubble, but then the maintaining of it and then, thousands of science discoveries from that. So with that, John, do you want to introduce yourself and your background in this area?
Sure. As you heard, my name is John Grunsfeld. I'm actually an astrophysicist and was a practicing scientist before I became an astronaut. And in 1992 was selected as an astronaut. I flew 5 space shuttle flights. And as Al said, 3 of those were to the Hubble Space Telescope. And in fact, we're really lucky today that in the audience here we have Drew Feustel, who is also a very experienced space flyer and was my spacewalking partner on Hubble. And we're about to celebrate the 33rd anniversary of the Hubble Space Telescope, 33 years on orbit. And the only reason that Hubble is still a world-class observatory and won Nobel Prizes and, as you said, an enormous amount of science, tens of thousands of scientists around the world, is because we did 5 space shuttle servicing missions to go up and put in new cameras, new scientific instruments, repair things that weren't working right. And specifically, Drew and I did what at the time was called brain surgery equivalent on Hubble, where we removed tiny screws from a cover plate and pulled out individual circuit boards and replaced those circuit boards to bring the Advanced Camera for Science, the ACS, the workhorse deep camera, back to life. At the time it wasn't working. And the science that resulted from that resulted in the award of the 2011 Nobel Prize in Physics. So if we'd screwed up, there'd be no Nobel Prize in Physics for Hubble.
So John, I'll leave this on. So John, so Hubble was intentionally made to be serviced. And this was in the era, early shuttle days, that it was being developed and thought about this. Shuttle was part of that future of serviceability and frequent up and down mass. Can you just talk about that era? And it inspired a lot of astronauts. It probably inspired you to go into astrophysics or at MIT. So can you talk about that era and what you were thinking at that time?
Oh, absolutely. In fact, when I was in high school, I remember ordering 3 posters that said "Going to work in space," and that's because I just assumed that by the time I was, an adult, by the time I was a professional, that space access would be routine, and that was the great hope of the space shuttle program, and I think it achieved that. It wasn't routine in the sense that no space flight is routine, but we regularly had access to space. And so in the 1970s, the Hubble Space Telescope was specifically designed to fit in the payload bay, to be deployed by the robotic arm on the space shuttle, and as we've been talking about, for astronauts, women and men in white suits, to go out and do servicing missions. The success, I think, of the Hubble Space Telescope early repairs is what it gave us the confidence that we could build the International Space Station, which is also serviced by astronauts and robotics, and was uniquely enabled by the space shuttle, on the U.S. side. So all the elements had to fit in a space shuttle bay. The avionics was designed to be replaced. And I think between Hubble and the International Space Station, we've really proven that both human and robotic servicing is, not only viable, but a good idea. What's so interesting now is, NASA is moving towards, exploration missions, and clearly when you're on the moon, if something breaks, we'll have to fix it. But there's an enormous industry, all you have to do is look around here at Space Symposium, of companies, including Redwire, looking at, robotic arms, looking at rendezvous, proxops, docking systems, refueling systems, mission extension, all around an in-space servicing architecture. In fact, yesterday we just heard that the Cosmic ISAM committee, if you will, group is being formed by NASA to help enable this. The White House put out an ISAM document that helps guide at least federal agencies. So there's an enormous interest around space servicing. Right now, not too much with humans, but robotically, but we've come a long way. And the question is, will all of this capability that's being developed spur on a new generation of spacecraft? And, spacecraft could be a ComSat, could be an observation platform. Will it spur on a new industry for serviceable spacecraft, like Hubble?
Right. Right. So you mentioned something that reminded me. When I was in high school, I had a poster of a open window with a curtain flapping, and on the table in front of the window was a astronaut's glove and a helmet, and but outside the window was actually the blue marble. So that image of working in space and looking back at Earth, I mean, that was what we were expecting.
Well, that's great, because I lost that glove, and I've been wondering where it went all these years.
So you touched on a couple things that I want to go back to. So first of all, NASA has been progressing in ISAM documents, in objectives and implementation plan, and not just NASA but the nation, and then a consortium. Can you talk a little bit about that progression and that effort to roll into implementation?
Well, one of the things that wasn't mentioned is I did a stint at NASA headquarters, and following on the Hubble missions and as associate administrator, my passion for space servicing extended into the policy realm, and I really tried to help kick off a new generation of servicing demonstrations, and worked with then Director of Earth Science Michael Freilich to do a demonstration to solve a problem, which was Landsat 7 running out of fuel. And so we initiated the Restore-L mission, which is now the first of the Space Technology Mission Directorate OSAM missions, Orbital Servicing and Manufacturing, OSAM-1, which is still in development to go up and refuel Landsat 7. I thought by 2017, Landsat 7 would be burning up in the atmosphere, but it's still going thanks to a quiet sun. And that mission is still going, and hopefully it will launch soon. So that was kind of the start of Space Technology Mission Directorate embracing actual technology demonstration missions to do, for the case of that, refueling plus a robotic arm to do some other operations after the refueling, such as building an antenna. And then OSAM-2, which of course is a Redwire mission, is to demonstrate manufacturing in space, the M part. And that's still on track, hopefully for a launch either later next year or early the following year. I'm not sure what the exact schedule is. And that'll be pretty spectacular. But NASA has embraced, the ISAM. It's just an acronym change. NASA's famous for acronym changes, to help enable, future servicing and manufacturing. And there was a lot of activity at the administrator level to come up with some policy statements. Then with the White House that resulted in the ISAM, policy document. What I'm hoping is that the federal budget will, help spur on government investment so that, industry, has some certainty that there'll be at least government customers, and that will then follow on and help, commercial customers. I'm thinking, like Orbital Reef, one of the commercial space stations, or something in, a Sunsync orbit perhaps.
So John, on that, as you mentioned, you are a scientist first. What are the science drivers of, getting payloads up there, taking co-located measurements, simultaneous measurements? Talk to that, and what's driving the potential for persistent platforms that have the potential to co-locate instruments in orbit?
One of the programs that I think the Science Mission Directorate should be very proud of is the Earth Venture Instrument Program. And so this is one where investigators at academic institutions, at FFRDCs, laboratories, universities can apply to get funds to build an instrument, and they don't have to worry about the launch and installation and power data, cooling. And we've been very successful. In fact, I think it's one of the greatest successes of the International Space Station is we've literally festooned the outside of Space Station at all of the data ports with instrumentation, mostly earth science, to be able to prove out new instrument technology. And almost universally, those instruments have transitioned from research into providing, highly valuable data, not only for the scientific causes, but for farmers, for land use managers, water managers. And so we've shown that a platform where you robotically install, the Earth Venture instruments are installed by the Canadarm on station, but controlled from the ground. We've installed these instruments, including astrophysics and heliophysics, on the International Space Station, such that there's now not enough room on the station to accommodate new instruments, and we're having to take, working instruments off and stow them, or, burn them up in the atmosphere. And so we've proven that a persistent platform for Earth observation and astrophysics and heliophysics is an extremely valuable tool, and the economy is that the investigators don't have to, buy a rocket, because NASA provides that as part of station services. They don't have to provide the communication system. So the big question is, what are we going to do after station? We're 7 years away from the planned decommissioning of the International Space Station. I think there's, high value to have a platform that would be dedicated to science, that would be dedicated to Earth observation specifically. And the high value is really that once you have co-located instruments, you get synergistic science. If you have two different wavelengths, for instance, maybe a radar and a hyperspectral instrument looking at the same part of the Earth, you find that, hey, we're seeing the Earth in a whole new perspective. And that's something that you don't get when you have individual satellites that are separated physically in their orbit, looking at the Earth at different times a day, for instance, or separated by time, like years. And we've proven this with the NASA A-Train. The A-Train is a train of satellites separated by minutes to half an hour or so that fly the same orbit so they can look at the same part of the Earth as they fly over. They don't want them too close because they don't want a collision. They would like them as close as possible, so that's a management issue. And that was the 1980s solution, is fly individual spacecraft, individual buses, with maybe 2 or 3 instruments. But the station proved that, well, we don't really need individual spacecraft buses. We could put them all together. And so I think that's something that, I know you've been thinking about and Redwire's been thinking about, but would really advance, not only from an economic point of view, that you save money, but advance the science. Because now if you have a new instrument that comes up, you can calibrate it and validate it against an existing instrument that's already proven. And that's one of the hardest problems in Earth science right now.
So that's interesting to think about, similar to Hubble, where the instruments are co-located, the telescope is there, the platform is there, and you, over 3 decades and others, were able to go up and put up new instruments that weren't even envisioned when you first had the platform, right? The science advanced over the decades, and new instruments were proposed and funded and built and then delivered to the platform, the persistent platform that is Hubble. And those kind of things can then be translated to Earth science persistent platforms or heliophysics persistent platforms in the future.
Well, in fact, I think that's the greatest contribution of the Earth Venture Instrument Program flying up to ISS, is that we've really advanced the pace of scientific discovery by allowing the people who are expert at the science measurements to build new, higher risk instruments and get them up quickly, rather than also having to worry about acquiring a spacecraft, a launch vehicle, doing that integration and test, and then waiting for a launch slot. And so it's taken years off of the time it takes to get an instrument to space. Now, when I've talked to some of my colleagues in the scientific community about this, they've said, well, we don't think the robotics is proven to be able to install the instruments. Or we don't think that rendezvous and proximity operations and docking is proven. But we've proven all of those things and the interfaces with Hubble and the International Space Station. There are no unknowns in making something like a persistent Earth science platform happen. It's just the willingness of somebody to build it and the customers.
Absolutely. In fact, I think the evolution of space station, where initially there were a lot of spacewalks to maintain, and then it started to be more balanced with robotic activity that's even operated from the ground. And now with the visiting vehicles, the berthing, I think, is done on orbit by the astronauts, so with the robotic arm, using robotic arms, but then the unpacking of the Dragon trunk is done from the ground robotically. So there's more and more of that that's being demonstrated. There's RPO and robotics being demonstrated from everything from CubeSat to new habitats being deployed.
Well, and even the Crew Dragon now docks autonomously with the crew there to provide an override in case it looks bad.
Yeah. And as we get to the lunar surface, surface mobility is going to advance the autonomy and activity and safe operations quite a bit. Let me go back and give you a chance to talk about the consortium that NASA announced, and I think they rolled out this week. Can you talk a little bit about the ISAM consortium there?
Well, I only know what I read in their announcement. And so so there's a few guiding documents out that describe, the interest, and I think that it's currently open to membership, and so anyone who has an interest, can express that interest, and and then there'll be a steering committee, like any good, NASA group, and I think the steering committee will also come from the community, and so this is really an outstanding opportunity for the both scientific, the nonprofit, like FFRDC community, research labs, universities, unless I said that already, to come together and start working through the issues of how do we make this, assembly and manufacturing and in-space servicing future, really happen. And my hope is that this will guide NASA programs and NASA funding, but it's also going to be a coordination facility so that we can start working on standards, because that's a big deal. You wouldn't want to go up to a satellite and find out, oops, I have the wrong docking interface, or power or thermal or comm.
So on that, by the way, I'm gonna after this question, I'm gonna open it up to any audience questions. So please, if you have any questions, this is your opportunity to hear it straight from John. But let me ask you, right before we started, you were talking to me about the potential for the next Hubble service, meaning that it might be a reboost of Hubble that is done either robotically or who knows, maybe with astronauts. But can you talk about the vision there, or what at least your maybe personal? I know you're not going to talk for NASA on this, but what your personal vision is there?
Well, because Drew Feustel's in the audience, I think my vision is that we acquire a capsule and do a Space Cowboys thing. Scott Altman is somewhere in the building. He was our commander on STS-109. STS-125, also 109. But Drew and I were on STS-125. And the very first technical task that we did on STS-125, that was May of 2009, was to install something called the soft capture mechanism. And it was basically an adaptation of the low impact docking system. And I was in the booth here yesterday and saw something that looks a lot like that. Right now there are no planned servicing missions to Hubble, and quite frankly, Hubble doesn't need it. Everything that's super important is working. We are single string on some systems. Hubble was built with an A-B redundancy, so if something fails, you switch over to B. And I hope Hubble keeps going for another 10 years. Sometime in the 2030s, Hubble will be so low in the atmosphere that it won't be able to point steadily, and that's really when science stops. And that depends largely on how active the sun is and atmospheric drag. So there's several scenarios, one of which is somebody comes up with an idea and the funding to actually go up and do a servicing mission. And the most valuable thing would be if there is an opportunity to put a new camera, new scientific instrument on board. NASA currently has plans for the Roman Space Telescope, which is a wide field near-infrared telescope, and that will follow on James Webb, and that's going to do deep fields much faster, and one camera shot, so to speak, will be 200 times the size of the current Hubble deep field. So that'll be amazing, but it's not an ultraviolet telescope. NASA is just starting the work on the next ultraviolet optical telescope, like Hubble, visible wavelengths. It probably won't fly until 2040. So sometime between now and 2040, either we reboost Hubble so that it can continue operations or a servicing mission, or when it gets low enough in the atmosphere, it may be a requirement to deorbit Hubble into the satellite graveyard in the Pacific. Just because it's so large and heavy, there is a risk number that it hits a populated area. In either case, you need to be able to have a rendezvous, proximity ops, and then docking to the bottom of Hubble on that interface that Drew and I installed. And I mean, at least that's what we designed that for. And so I think that's an exciting opportunity.
Yeah, I think it's an important point to note, just like with other future platforms, that James Webb isn't a replacement of Hubble, and the future telescopes aren't necessarily a replacement. The science is dependent on the spectrum and the collect method and so forth, and they're complementary, or they're advancing it. So it isn't one after another, but all together. That really is pretty amazing for the science community to have.
James Webb is a good example. Hubble was designed for what I call extreme servicing. Every doors on the avionics bays, accessible connectors, EVA friendly for many of the things. And James Webb Space Telescope is at the other extreme, no servicing. I did manage I encouraged the team at least to put on some stickers that would be fiducials if we ever did go to James Webb, but it's a very delicate system, and it's a puzzle, integrated all together to do any real servicing. But amazingly, James Webb's lifetime requirement, I think, was only 5 years. The fuel limit looked like it would be about 11 years, and I want to thank the Ariane space team because they were so perfect in their launch that we didn't have to use virtually any fuel to get out to Earth Sun L2. And so we could have James Webb for about 20 years. And Hubble and James Webb work together superbly. So it'd be great to see Hubble last a little bit longer.
Yeah, that's awesome. Let's see, I do want to open it up for any audience questions, although I have some questions, and I am here, a spoiler alert, I'm going to ask John about what he remembers most about being in the guts of Hubble before we end, but why don't we open it up for audience questions?
Hi, John. What is your favorite memory from Hubble?
So I'll give two memories. One of which is I was inside repairing the advanced camera for surveys, which put my feet in the telescope, and I had a face full of the instrument, the advanced camera for surveys. Couldn't see outside at all. And Drew was outside helping me at that point, and he said, "Oh, wow, look at Hawaii." And of course, I couldn't look at anything. So, and that was kind of our inside joke. I was inside. But, you know, I have many great memories of Hubble and many stories I could tell. But really, it was in 1999, December, my first Hubble mission, my first spacewalk. Steve Smith and I were outside. I had just gone out of the hatch. I was on the end of the robotic arm, and Jean-Francois Clairvoy was bringing me back to the telescope so we could start work. And there was just a moment where I was in disbelief that I was orbiting the Earth, 17,500 miles an hour. I could see the Earth going by, looking at the shuttle wings, and there was the Hubble Space Telescope. And as an astronomer, that's the holy grail of telescopes. And so it was kind of silly, but I was about a meter away from the telescope, and I put my arm out in one finger and touched a handrail just to kind of, it's like pinching myself that it's real.
So there was not do not touch sign anywhere on Hubble when he got there?
Basically, our rule was don't break the telescope, because almost
telescope.
Everything is do not damage.
Yeah, right.
And that's a really interesting point, that Hubble was designed to be serviced, but most of Hubble is easily broken. And I think that was a lesson, that we learned, that we applied to Space Station, where we made Space Station, pretty rugged. Not entirely so, but human-proof.
So you mentioned something that reminds me. Do you want to tell the story about the one thing that you guys did intentionally break on Hubble, or Massimino maybe broke?
Sure. The day after Drew and I fixed the advanced camera for surveys, it was Mike Massimino and Mike Good's turn to go out and repair an instrument called STIS, the Space Telescope Imaging Spectrometer. And just as an aside, my current observational program on Hubble uses STIS. So it's really important that he was able to fix that. But one of the things he had to do was to remove 130 tiny screws, but before that, he had to remove a yellow handrail that was put there for us to hold the instrument during installation. And it had 4 number 10 hex cap screws, beefy screws, big screws, and he had essentially a power drill with a hex bit on it, and he went to remove those 4 screws, and in the process managed to strip the heads of actually 3 of the 4. Fortunately, 2 of those came out still from just friction, but one of them was completely rounded out and wouldn't budge. And so we had a handrail that had 2 bolts at the top, 2 bolts at the bottom, about that big, and one of the screws at the bottom wasn't coming out. And so you could move the handle a little bit, but until we got that handle off, we were stopped dead in our tracks for about 4 hours. We struggled with that, and the team on the ground, was working it, and Drew and I were looking through the drawings and bolt sizes and thinking about, what we had, and we actually came up with a socket that could remove the big bolts that hold the handrail on at the base, but it was inside with us. And those guys are already outside, and cycling the airlock, that'd take a lot of time and would be a big deal because you'd have to bring the crew in case a door got stuck or something. So that wasn't an option. Plus, we didn't know what was on the other side of the bolt, and so we proposed that to the ground, and they said, okay, we'll look at that. Finally, some of the engineers, including an engineer named James Cooper, who also races open-wheel cars in I think Formula Ford. So he's a fix-it guy and a mechanical guy. Anybody who works on car engines and cars knows how to fix things. And on the ground, they came up with an idea. They built a mock-up. They tested it, and they said, well, with about 60 pounds of force, you can pull the handrail and fail that one bolt in tension, get the handrail off. And so 4 hours into a 6.5-hour spacewalk, turned out to be 8 hours, Mike Massimino grabbed that handrail and bent it a couple of times, and one mighty pull, and boom, it came off.
I love that story because it just shows how real it is, just like working on a car or fixing something at your house. Sometimes you have to deal with stuff as they are and not the theoretical or as designed or built. And astronauts and people living and working in space in the future are going to have to deal with the reality.
Yep, and that's something that favors humans because we're so adaptable. You might not have designed the robot to rip off a handrail.
Yep.
I'm still surprised that Mission Control, the flight directors, that they let us do that. So
yeah, but I love that.
But Mike Massimino's expendable, right?
All right. Okay, Drew. I'm going to put this on record. Drew is saying that the video was actually turned off when they told him to do it, so it's probably in an archive somewhere saved by Mike. But yeah, I imagine that if it was allowed to be discussed very much further than the crew, that might not have happened at all. Any other questions? I want to make sure to give an opportunity for the audience here to ask or make comments or say anything. And I know that there's a number of people that have aspirations to be an astronaut or just enjoy hearing from him.
Question on my end, and speaking about installations, so on one of the next resupply missions to the ISS, the Redwire team is going to be very instrumental in the IROSA panels that will be going up to the space station. Can you talk a little bit about the importance of these types of solar panels, what might be a little bit different about them versus what we presently have on station, and the impact that might have on the viability of station moving forward?
Well, the really big picture is, station, we're 23 years on orbit with humans, and the solar arrays degrade over time. They're silicon solar arrays. Hubble, on the other hand, we had a picture of Hubble up there. We had rollout silicon arrays on Hubble when they were launched. They were replaced in 1993 because they were too flexible and caused jitter in the telescope. They were built by the European Space Agency, and they worked great. But finally, in 2009, we replaced them with gallium arsenide rigid solar arrays, which are the arrays that are currently working. And those are triple junction, high output solar arrays, and they're great, but they took a space shuttle to get up there. Same as with the solar arrays that were launched up to the International Space Station when they were built, but the output of the current solar arrays is down quite a lot. And one of them is damaged. We had a tear. And I'm not an expert on the rollout solar arrays, other than that they're built by Redwire, but they're going to provide new power, to power station through the rest of its lifetime.
Yeah, let me just say a couple quick things on rollout solar arrays. And we have an image up here just to give you a sense of the magnitude. And everybody's probably seen there's been 2 sets already delivered and installed by astronauts and then deployed. Amazing footage if you ever have seen astronauts outside or deployments, but having astronauts with deployments occurring is pretty phenomenal to see. And there's another 2 solar arrays that we've delivered that's going to be being installed there as well. And it'll allow the operation of station through the rest of its life. So very proud of that work. And this bodes well for future habitats and destinations to have a lot of power to operate in.
Yeah, I was going to just say, you can never have enough power. More power and more power tools.
That's true. The more power we have, the more power tools we can take up.
Actually, yesterday we were having a casual discussion that this type of rollout solar array also gives you the potential for power on the surface of the moon. That as you roll them vertically now against the third of a G, sixth of a G, you can create quite tall structures, which at least in the South Polar area will be very important.
Yeah, the beauty of the moon is that it's rarely cloudy on the moon, and the days and nights duration, so you can design a electric power grid, solar power grid that supports the habitats and the activities that we're planning, and that is one of the things that we're very excited about working on at Redwire. Is there another question in the audience that anyone has a burning question? So please raise your hand if there's a mic here. But let me ask you, John, just going back to the future platforms for science and the future of not only Earth science but others, what could you envision in 10 years or 20 years being available or done, and where is that all going as far as the Science Collect potential?
Well, one of the things I imagine is that between the James Webb Space Telescope and some of the large aperture telescopes that are being built on Earth, the 30-meter telescope by the U.S., the Giant Magellan Telescope by the U.S., these are 20 to 30 meters across ground-based telescopes, and then a 38-meter European extremely large telescope. And then James Webb, which is exploring new ground in the early universe. I think we're going to see some scientific revolutions where we learn about how the universe really formed, not our theoretical view, but what was really happening when the first galaxies, first stars, first black holes were formed, that will drive the need for other space observatories. One of the ideas that Jack Burns from University of Colorado and a team has come up with is to put a low-frequency radio telescope on the far side of the moon. It's too noisy here on Earth for low-frequency radio telescopes, and that can probe the time period of the universe before there were stars. And that's something that could be enabled by robotics on the moon or humans on the moon. But I think there'll be, you think about, the pictures of, detailed pictures of a black hole, the gravity wave observations. We're entering these new realms of looking at the universe in different ways that's going to drive our needs in space. And, I believe anyway that sometime 10 to 20 years, we're going to decide to assemble a very large space telescope, specifically for what I find to be the most engaging question, which will need a 16 to 20 meter aperture. James Webb is 6.5 meters. It's already big, but a lot of things in space are really dim. And if we want to find out the answer to the question of are we alone in the universe, by looking at a planet about the size of Earth around a sun-like star where the orbit is about the same, so you're in the habitable zone, we're going to need probably a 16 or 20 meter telescope to actually interrogate that atmosphere and see if it's habitable, and more importantly, if it's inhabited. And we can do that with proven technology as far as the assembly and station keeping and pointing and all of that. The scientific instruments are challenging because an Earth around a nearby star is 10 to the 10 times dimmer. And so people are working on coronagraphs and which block out the starlight and the ability to see that. But in 10 to 20 years, we'll have that technology. I think it's easier to assemble a telescope that large than to try and figure out how to launch it like James Webb.
Yeah. That's pretty phenomenal. The ability to actually view, direct view of exoplanets and investigate and understand what exoplanets are out there and the potential for life out there, and be able to measure that directly is within a couple decades away by building these telescopes.
It's within our grasp. It's just a will to go do that. And in fact, today we saw a spectacular test of a very large heavy lift rocket that may be the kind of technology that once it's successful enables us to launch very large aperture telescopes, not only to enable human exploration and other things.
Yeah. So with the advent of super heavy lifts like Starship, New Glenn, even Neutron at 7 meter fairings or 8 meter fairings, I mean, you have the potential of putting up a solid 6 meter, 7 meter primary mirror on its own now versus having to fold it, and then even assembling much larger platforms going forward.
Yeah, I mean, with a New Glenn or a Neutron large fairing or a Starship, you can imagine putting up a telescope that has a 16 meter aperture in one launch with only a few pieces that
Right.
you have to assemble.
Right, that's an exciting future, and I'm sure that next Space Symposium we're going to have even more advancements of these are launching and the potential of what people are going to do with that. So we're going to wrap it up here. I'm going to give John 1 minute here to give any final closing comments, but first I want to express appreciation for everyone, not only for today, but for throughout the week. We've had a lot going on at the booth. It was all, I believe, on YouTube, live streamed and accessible, and the audio is awesome. So if you did miss something, please go back and listen to it online. So kudos to the audio-video team, to the Marcom team here at Redwire, and everybody who's staged the whole production this week. And with that, John, do you want to give any final comments, vision, and especially inspiration for the space generation and early careers who have now the potential of going into space and building out the next science platforms?
Well, the first thing I'll say is I think the Space Symposium has evolved over time in a very good direction. One of the things that, 20 years ago we had a huge challenge, and I think is still here, is that, scientists aren't the only ones who put up telescopes in space. And we've seen really, a complete renaissance of Earth observing, for instance, telescopes looking down at the Earth, instruments looking down at the Earth, from CubeSats, from Planet to Maxar, larger imaging apertures, and instruments that have given us coverage of the Earth that is both inspiring, but is also giving us the critical information we need to know how to address climate change. And at the Space Symposium this year, there was an extremely strong science track that gives a view to our defense communities around the world who are also here, a much better idea of what we're doing and what the demands of science are, so that we can actually cooperate on technology rather than trying to develop them independently. And that's been the challenge over the years, is that the defense community doesn't learn about what we're doing in science, and deliberately the defense community activities are kept from the scientists. And so bringing people together from both realms is extremely important. The other thing that you can see is there's a fair amount of science fiction here. There are things that are exciting, and this is just my own opinion, but mining asteroids in the main asteroid belt, is science fiction. There are some people here who will be alive when we do that, but it's in what I call the far field. But space servicing, for which there's a lot of exhibits and talks and discussions, that's here today, and that we ought to really embrace that and start using it, because we know how to do it.
That's awesome, thanks. And with the message of collaboration and huge aspirations, which is pretty much descriptive of our industry, I want to thank you very, very much for your time, and I want to thank everybody, and with that, it's drop the mic, end of the broadcasting, and appreciate everybody's attendance. Yep. Thank you.
Live long and prosper.
Thanks, John. Appreciate it.